In this video, we will discuss methods to compare decimals and fractions and use inequality notation to express their order. We will use a few methods to accomplish this. So first, we're going to be given a fraction and a decimal and asked to compare them, and we can determine their order in one of the following ways. So we could rewrite the given decimal as a fraction and use methods for ordering fractions that we've already learned. We can rewrite the given fraction as a decimal, then we'd be comparing two decimals, and then use methods for ordering decimals that we've already learned. Or the easiest way, I think, when it applies is use benchmarks such as 1/2 when possible to order the numbers. So let's look at our examples. Determine which number is greater. Use the symbols less than, equal to, or greater than to express this relationship. So first let's note that our benchmark that we like to use with fractions is 1/2. 1/2 is equivalent to 5/10 as a fraction, and as a decimal or as a decimal fraction, 5/10 is 0.5. So looking at the first example, we want to compare 5/8 and 0.5. Well, first, we know that 0.5 equals 1/2. Now let's compare 5/8 to 1/2 and see if we can use that relationship to compare these two numbers. Well, to compare 5/8 to 1/2, remember we divided the denominator by 2, and we would get 4, so 4/8 equals 1/2. Since 5/8 is 1 more eighth than 4/8, we also know that 5/8 is greater than 1/2. Okay. So now we have two numbers. This is greater than 1/2. This equals 1/2. So now we know 5/8 is greater than 0.5 or 5/10. Let's look at the next one. Okay. So now we have 3/8, so we already found that 4/8 equals 1/2. So 3/8 is less than 1/2 because 3 is less than 4. Now 0.64, well, 6/10 is more than 5/10, so we know that 0.64 is greater than 1/2. So if this is less than 1/2, this is greater than 1/2, then 0.64 must also be greater than 3/8. Let's look at the next one. Okay. So let's see what 5/7 or a fraction with a denominator of 7 would be that equals 1/2. So when the numbers are odd, it's a little weirder, but dividing 7 by 2, half of 7 is 3.5. So 3 1/2 sevenths equals 1/2. Okay. And 5 is greater than 3.5, so 5/7 is greater than 1/2. Okay. Now 0.28 compared to 0.5, well, 2/10 is less than 5/10, so 0.28 is less than 0.5. So this is less than 1/2, this is more than 1/2, so 5/7 is greater than 0.28. So remember, all of those we could use this method because one of the numbers was greater than 1/2 or equal to it, and one was less. Okay. Let's look at the next one. We want to compare 4/9 with 0.44. Well, half of 9 is 4.5. So 4.5 or 4.59 equals 1/2. Okay. So 4/9 is less than 1/2. And 0.44 is less than 0.5 because this is 4/10, that's 5/10. So we have 0.44 is less than 1/2. So since both of these numbers are less than 1/2, we're going to have to use some other method because the benchmark method isn't working. So we could write this as a fraction and then rewrite it with a common denominator, but that ends up being a lot of work. It's a lot easier just to take 4/9 and use division on the calculator. So 4 divided by 9 is 0 and then 4s that go on forever. So let's write these numbers lining up the decimal places. So first we have 0.44, and then that terminates. And then 4/9 is 0.44. I'm going to put a few 4s and then a dot, dot, dot. Okay. Now when the decimal terminates, we typically don't write it, but remember that means that all of these decimal places are 0. So if we want to compare these two decimals, after filling in the zeros, we can compare by place value. So starting with the decimal, these are the same, these are the same. And notice when we get to the thousandths place, 4 is larger than 0. So that means this number is larger. Remember, this number is the decimal expression for 4/9. So 4/9 is greater than 0.44. Let's look at the next one. Okay, let's use the division method again. So first I'll write 0.64. And now I'm going to divide 7 by 11 to write it as a decimal. And I'm going to write a few decimal places. So we have 0.6363, etc. 0.6363, and that continues on. Okay. Now let's put in our placeholders. And we'll compare these from left to right. So here the decimals are the same. They're both 6. Here the decimals differ. Okay. So 4 is greater than 3, so that means 0.64 is greater than 7/11. Okay. Now notice if we had rounded this, that would have been a mistake. If we rounded this, it would equal 0.64, but that would be an approximation for 7/11. That's not what 7/11 equals. So don't round before you compare the decimals. And let's look at the last one. We want to compare 0.62, and now I'm going to divide 8 by 13 to find its decimal approximation. And we have, I'm going to write about 4 decimal places, or 5. 61538. 61538. Okay. Now if we fill in the placeholders and now compare, they're the same in the tens place and they differ in the hundredths place. And again, if we had rounded this, that would have been a mistake, okay, because we would have that they were equal. So you don't want to round, you want to compare them until you find a difference in their decimal place. And we see that 0.62 is greater than 8/13.